talk louder? Is that better? Alright, I'll just yell at you guys. Alright, well, my name is Matt Szymanski. I run an offensive security team for a company called Red Ventures out of North Carolina. Not a lot of people know who I am, or who Red Ventures is, or, those are both true. Some of my contact information, my Twitter's pretty empty, I don't really tweet that much. But I like skydiving a lot, so if there's any skydivers in here that want to chat later, hit me up. Nothing I say represents the views of my employer, blah, blah, blah. Gotta say all that, right? Today we're going to talk about GraphQL. Does anyone know what GraphQL is? Have experience with GraphQL? Okay, awesome. Has anybody ever pen tested a GraphQL endpoint? Alright. So you know that it can be kind of a pain to go through it all, right? So hopefully today we'll learn some techniques to help you get through it. First we're going to talk about kind of what GraphQL is for the people who don't know. Give you kind of just enough information you need to know to understand it. Then we're going to kind of learn enough about it to be dangerous in that way. We're going to check out some vulnerabilities that have actually been found in the wild. Talk about how to abuse GraphQL's built-in functionality, some attack techniques. Short little tidbit on how to protect GraphQL. And then we're going to check out a tool demo. So, what is GraphQL? Right? GraphQL was essentially created by Facebook for internal use in 2012. It was released publicly open source in 2015. It's essentially a query language for your API and a server-side runtime for executing those queries against a type system that you can define for your own data, which gives you a whole bunch of flexibility of how you want to design your schema. It's designed to solve a lot of problems that come with REST APIs, mainly having to make shit tons of queries to get enough data to populate your admin dashboard, right? So GraphQL basically condenses all of those REST endpoints down into a single GraphQL endpoint, and subsequently, instead of making 50 requests, you can make one single request for a large amount of complex data and get it back in a single response to parsers. You can implement this with your existing code base, which a lot of companies try and do. It's going to take a lot of refactoring, which with that comes, you're introducing additional problems. People don't necessarily understand how to properly do it. The business side is pushing on them to hurry up and get it done faster. The engineers learn just enough to get it to work, and they don't fully understand the security implications of what the things that they're doing are. So, like I said, with that increased complexity comes increased room for error. GraphQL kind of adds another piece to an already complex puzzle, as these web applications out there are getting more and more complex. You can still attack all the underlying code base beneath it. We just need to know the new path to get there. So we're going to also leverage all that added complexity to look for implementation errors along the way, because those are pretty common. So here's a super annoying slide, but I just wanted to give you an idea of all the big names out there. These are just the people from GraphQL's homepage that I did a curl request, grabbed all of these images from a carousel that have been a big annoying GIF for you to see that tons of people are using this technology. It's all over the place. As this, the popularity grows, it increases the chances of a compromise. Pen testers don't always understand how to properly test this new technology, so they miss things. But we all have problems, right? While the developers are out there poring over all of this documentation, trying to understand how to properly use all this, as attackers, we have to do the same thing. There's just, hundreds of pages of documentation to read to fully understand the technology, because you can't truly test the technology unless you understand how it works. So I'm going to teach you just enough to get by. It's also based on the concept of a schema. If you've ever worked with a SOAP API in the past, then there's the WSDL file. It kind of has the same type of thing for GraphQL. But these schemas can be enormous, and we'll talk about that a little bit later. Reverse engineering these schemas can be extremely time-consuming, and there's not really a lot of GraphQL-specific attack tools available to help you do this. So it's a lot of manual work. No one really likes manual work. As attackers, we're all pretty lazy. We like automation. We want to push buttons, get information back, be able to, do. The fun part is parsing through that and figuring out, what went wrong. At the end of the day, it's the same vulnerabilities that still exist in all the web applications out there. It's the same OWASP top 10 sitting behind the GraphQL. So we just have to figure out a new attack methodology for the new landscape, how to get to it. So let's get to know GraphQL a little bit. To show you just the basics of what you learn, right? So schemas are basically collections of objects and type definitions, along with a few other things we'll talk about. Each field in your schema maps to a resolver function, and that resolver function is what passes all your user input into the underlying code base, right? Which is usually JavaScript or PHP, oftentimes when it comes to GraphQL. This is where all your application logic lives, so it just kind of rolls downhill. This is where our attacks are normally going to take place. So we just got to figure out how to get our payloads through the GraphQL layer and into the underlying code. So let's take a little closer look to give you a little understanding of how this all works. This is a typical query to a GraphQL endpoint. This is contrived and extremely simple. Actual queries in the wild are much more complex than this. But let's say we wanted to make a post request to myaustinAPI.com/GraphQL. Our payload is basically going to be, we're asking for a hero object and the name field for that object. In response, we get the same shape response as the request that we send it. So in this case, we ask for the hero's name, we get RGD2, right? Each field is of a scalar type, and GraphQL comes with a few built-in scalar types. In this case, it's a string. If you're familiar with object-oriented languages, this is the same type of concept as having an object with parameters on it. And in that same vein, just like you can have an object as a parameter on another object, you can do the same thing in GraphQL and nest them down. So this object is going to query for network gas for the hero, his name, and all of the hero's friends and all their names. You know what to expect as a response based on the schema. So in this case, we get the hero's name back. It all follows the same shape. We get a list of all of his friends and their names. These are also all type string. We'll get into a little scalar type a little bit later. So those queries in the back end, how do you build this schema? How do these developers create this mapping? Basically, you have types, and in this particular case is an object type of hero with a scalar type field of name, return the string. The exclamation point means that it's not nullable. The brackets around friends means to expect a list or an array in response. So by looking at the schema, we can derive exactly what's expected of us to send as a request to get a proper response back. So, like I said, GraphQL comes with a built-in set of scalar types, but you can also implement your own custom scalar types. And as defined in the documentation itself, if you're going to implement your own scalar type, it's up to the developers to implement the proper validation for that scalar type. So this is definitely someplace we should look into, because this is a place where somebody's going to make a mistake, not input, not set up the validation correctly. Maybe we can do something. So objects take arguments, of course. I can pass an argument into an object, and in this case, we're going to ask for a human with the ID of 1000. This is a good place where you can start to do insecure direct object reference. attacks against it. As a response back, we get the same shape as the request, and we get the information that we were looking for that particular user. So, all these same kind of concepts that were in REST APIs, we can send user IDs, all this stuff. It's all the same type of stuff. It's just all nice structured JSON and condensed from, dozens of REST API endpoints down to this single one. So that really decreases latency, right? So we don't have to wait for all these AJAX calls to return. We do it all at once. GraphQL does a really good job at speeding up the process in the back end. So that's great for developers. The concept of mutations is basically how you would update data on the server side. So if I'm going to send a mutation, I'm going to, the example of mutation here, I'm going to add a category with, all of this data in here with these attributes. And then the bottom section is where I'm asking, say, after this query executes correctly, this mutation executes. I want you to send this information back to me about the mutation that you just executed. So in typical REST API fashion, you have to, send the update request. Then you have to send another request after it saying, now give me the new data. And this is another little problem that GraphQL solves versus REST APIs. Lots of convenience here from a developer's perspective. But all this data is untrusted, right? And so it's really up to the developers to figure out how to properly validate and sanitize all this user input, which, just like you all know, fails often. So how do we know what all functionality exists in a GraphQL API? Well, like I said, introspection queries are how we get a hold of the GraphQL schema. So we can send it a giant introspection query that basically tells it, look, I want you to send me your entire schema back, or you can send it a tiny little introspection query to just get a little subset of the schema back you're looking for. To give you an idea of the size of the responses that you're going to get back, Spotify's 3,500 lines all the way up to GitHub, whose introspection response is 84,000 lines long. It's actually 84,007 the last time I checked. So, I don't know about you guys, but I'm not trying to sit and parse through 84,000 lines of response body to try and find what I'm looking for. Deeply nested queries, it's a wall of text, for sure. So we got to do something about that. GraphQL also has the concept of not overfetching, right? So typically with a database call, you can do a select star from whatever. GraphQL does not let you do that. You can't just tell it, hey, give me all the fields for this particular object, and it gives them all back. You have to know what the fields are that are mapped in the schema for that particular object, and explicitly ask for those fields to be returned to you, which isn't really an issue if you have introspection queries enabled, but when you don't, it's basically invisible now, right? Like we have no way to know which fields are available for which objects, so we kind of got to do something about that also. Okay, so typically with a GraphQL implementation, there's some sort of console available, or an IDE that developers use to kind of poke at their APIs, do some testing, write code, all that good stuff. The usual ones are called GraphQL Playground. There's one called Altair. They usually run as standalone Electron apps or browser plugins, and some even embed right into the developer tools of your browser. Makes it really, really convenient. We can use these things too to query these APIs and get some more insight into what's going on in there. They have a really feature-rich environment, and they basically leverage the introspection query response. They do a bunch of parsing on it and dynamically build all the documentation required for that API. So if you're trying to publicly share your API, having this available is really convenient. If you're trying to attack an API, it's also really convenient because now I get like this nice search bar. I can start searching through and filtering down to really find out what's available in here, what's interesting for me to try and attack. I would say, 20% of the time, from my experience, these are enabled in production environment. Right? So that's super awesome. I love that. So the generosity of the development community is really great when it comes to giving away information like that. There's some GraphQL implementations have the concept of debug mode. So you just attach this pretty little query parameter onto the end of your request, and it enables verbose logging for you up to full stack traces being sent back. It's pretty oftentimes they forget to change this flag when moving to production. It just kind of sneaks by. So this is a really great thing to always kind of attach onto your queries. Send some garbled user input in there, see if you can get full stack traces back. I've seen some pretty crazy stuff. So let's talk quickly about the GraphQL security model here. Let's say quickly because there basically is none. GraphQL has no built-in security authorization authentication functionality. As far as scalers, unless you're using the out-of-the-box ones, there's no pre-built validation for any of them. This is a snippet straight from their docs, and they're basically like, figure it out yourself. Right? It's up to you guys to figure out how to do all of this stuff. And just like you run into these problems all the time with REST APIs, where they're not doing field level authorization, authentication is messed up. It's the same type of stuff that you see here. This is just a more complex system, so the chances of them missing a piece of this are much higher. And this is one of these examples of how we can take advantage of these implementation errors. So let's take a look at some GraphQL bloopers in the wild, right? So I went to HackerOne and searched GraphQL. I just want to see what's out there as far as mistakes people are making, attackers catching them, and what kind of money can be made for bug bounty programs for GraphQL. Right. So this first one, pretty sinister. So apparently Shopify has kegs in all their offices. These kegs are hooked up to these fancy monitoring systems, like give them, like all this beautiful information about how much beer is left in each one. Right. So this guy just buzzed all of the subdomains for Shopify Cloud and found one called Beerify. Like, I wonder what's going on here, right? So he started sending queries, and he got back a list of all the Shopify office locations, and he derived from that information that he could query about the beer consumption. This was during a hackathon, so I guess their kind of social engineering attack vector was, now we know what kind of beer you love, we're going to send you a bunch of free kegs of beer, and you're going to give us a little head start on this hackathon, maybe a little bit. It was all in jest, but they ended up getting paid out $802.20, which is the price of 3 kegs of white beer for each one of the hackers. So, not a bad payout. I'll take 3 kegs any day. This one gets a little more serious. This was within HackerOne's GraphQL API itself. So, there's actually most of the ones in HackerOne are for HackerOne. I'll say that. So, it has the team object that you can query in the GraphQL API there. So this guy starts querying it, and he figures out that there's a huge authorization bypass, the logic going on there. He's able to return some really confidential data from the team object and basically derive how many companies at HackerOne are actually running private programs inside, right? So $2,500, not bad. Take that. Get a little more serious now. We all hate moving, right? And it's no different when you're trying to move to a new implementation of something. This is a pretty interesting one because I think it really highlights a typical problem in software development is when you're upgrading to a new version of a library or just a whole new implementation. People don't always understand the intricacies of it. People aren't going through all the change logs to figure out necessarily what has changed. They just upgrade and see what breaks, fixes things that break, and now we're good, right? So in this particular case, they were upgrading to a GraphQL Ruby class-based API. This new API by default, added a nodes field into their schema. But there was already a nodes field in their schema. It was just nested under another field called edges. So everyone just kind of assumed that, oh, this is just a shortcut to this edges node field. That's really convenient, so no one bothered to test it. Well, it turns out the new nodes field completely bypassed all authorization and authentication logic and allowed them to get a lot of user metadata from the programs at HackerOne. You can tell how serious it is by this dude swimming in money. He made 20 grand from it. Pretty awesome. This one, I don't know 100%. I think this guy works for HackerOne itself, so there was no payout disclosed, but it's pretty freaking serious, so wanted to kind of highlight it here. They introduced a new feature for embedded form submissions, and instead of taking the typical route and using a field input like they normally would when you're using fields, they decided that we're going to get super clever and we're going to use a GraphQL parameter instead. Well, they already had a bunch of functionality in place that automatically did validation and sanitization on all the user input data through forms. They did not have that same logic for GraphQL parameters. So no one bothered to check this. It went out live. This guy realized that he could just do a SQL injection attack since there's no validation happening, and not only was he able to access the public schema, he was also able to pull data from their secure schema. And I'm not sure what they keep in each one, but the one called secure sounds a little more dangerous to me. I'm sure they didn't want that data disclosed. I will add on a little side note that after an investigation, they determined that no data was actually abused or exfiltrated from this before it was found. But this is just an example of the stuff that you're going to find out there in the wild due to the complexity and implementation errors of GraphQL. So, move on. Talk about abusing GraphQL a little bit. I know maybe like half the people in the room know who that guy is. If you do, we're all working on it, right? So the first thing we have to do is locate all the endpoints. And by all the endpoints, I mean the one endpoint that they're using, which can be a larger task than you would initially think. Of course, they can be customized to be named anything, but here's a list of kind of like the typical names that you'll find out there from the available pre-built GraphQL implementation packages. They oftentimes put version numbers before them. You never know which version it's going to be. A lot of times behind subdomains. You can see the example for GitHubs at the bottom here is developer subdomain with a version 4 and Explorer. So it can take a while if you don't have a good lead on where this might be to kind of enumerate and use sublister to kind of go through and find where all these different domains are. WBuzz might be a friend of yours at that moment. But regardless, we need to check them all until we find the one that we're looking for. So you're either going to end up finding a console. If you find a console, that's great. Just open up, the inspector and grab some of the requests. The console location is not going to be the same location that it's actually making the request to. You can just grab from the network tab, grab the actual GraphQL endpoint from there, and start hacking. Also, don't forget to check debug mode when you're doing all this, because you might get some extra goodies. So we're going to use the introspection request for evil here. Once we do find that endpoint, we need to send an introspection query to it and try and obtain the schema. If the schema is enabled, then we need to determine all possible queries, mutations, and in some implementation, there's a thing called subscriptions, which I won't get into too much. It's basically like a WebSocket. You send a query, it opens the WebSocket connection. Anytime that query gets updated on the back end, it can push to the front end. I'm not going to touch on that too much. It doesn't really affect this. We're more concerned with how they're accepting our user data. So we got to test we got to build all of these queries, right? So how many queries are available in an 84,000 line schema, right? Like there's tons of them. So you have to go through this schema, figure out how to read the schema, parse through it, manually build all of these queries, and start sending these queries to see what kind of responses you get back, so that you can move on to start to send malicious queries in their place, right? This is an extraordinarily time-consuming process. I hated it. So I tried to do something about it. You got to be on the lookout for error responses, stack traces, all that good, juicy debugging data. Again, these responses can be very large. So here's just a little example here of. Right, so this is a console called Altair. I don't know if any of you guys played Assassin's Creed, but they reference it a lot in their repo. Super clever. So, I sent an introspection query, proxy into burp here. You can see, there's my raw request, and here's my raw response. This particular response is 3,279 lines long. So let's see what we can actually get information-wise from, 3,279 lines. That's not what I want you to know. So, this is a pretty cool tool that I found called GraphQL Voyager. You basically take the introspection query response and you copy and paste it into this tool, and it builds kind of an interactive ERT diagram, a top-down bird's-eye view of all the connections between objects and their dependencies and all the nested stuff. And it lets you click and it'll kind of highlight the flow through it. It's really valuable when you're trying to write custom queries. Just reading JSON isn't very intuitive. So this gives you like a really easy way to, this is the dependency of this, and this is the kind of scalar that it is that it expects, or it expects another object in response. So just wanted to throw that out there for you guys, that this is a pretty interesting tool to leverage if you're trying to get a better, overall holistic grasp of what this schema looks like outside of a JSON blob. So let's take a little closer look at what is actually in the introspection responses. Here where it's saying that we have a query that we can make for all. This is for a fictional, an example GraphQL endpoint that's out there called Snowtooth. It's set up just for fun to let you run queries on a fictional ski resort, right? So in this case, we can call and say, I want to get this all lifts, and I want to know the status of all of these lifts. So, we send in all lifts, and here's a second one. This one we can query for a specific lift by passing in an ID, and we can get the name and a whole bunch more information in response. Just want to give you guys an idea of what the actual introspection response looks like, and how much of a pain that's going to be to go through thousands of lines of trying to manually fill out all of this stuff. It's not real easy. So here's what an actual query for both of those would look like. I take that introspection response and I build some manual queries for it. The first one, you'll notice though it's nice JSON structure there. I'm saying, give me all lifts, and then give me back the name and the status for all of them. It hands me back, of course, in the same shape as my request, all of the lifts with their name and status. Pretty straightforward stuff. Here's the other one where I'm actually passing user ID in. I'm going to say, give me the lift with the ID panorama and the status of it, and then all the trails that lift can take me to, and along with the name and status of each of those. So, pretty straightforward. That's kind of what I get. Just wanted to show you guys some examples of the process of taking the response, building queries, getting responses back from those queries. Mutations. It's not often that you're going to get the chance to run mutations on a GraphQL endpoint without some kind of authentication in place. It turns out that people just don't like letting any old person write arbitrary data to their databases. I don't see why. It's not very friendly, but not much we can do about that. So what you're basically doing here is you're defining the structure of your mutation, and then you're calling a function, create review. So this is going to get mapped down to resolver at the end. Then you're going to pass it, a separate JSON structured data that is going to hydrate all of these variables, and you get the response back that matches the same shape. The second part under here, so you see create reviews, then you see starting commentaries. You're saying, after this query or after this mutation has been successfully executed, this is the information I want you to give me back after it. So again, we can do all of this stuff in one request. Super convenient. So what do we do if introspection is disabled? Right? We don't have access to their entire schema. Not gonna lie, the situation sucks. But there are a few things we can do, right? So first, something that's worked well for me is to just check staging and development subdomains for that same one. And oftentimes they're open to the public also. They have debug and introspection enabled because they think no one's ever going to find our staging domain. It's super hidden. No who would possibly know that exists. So then we just take that introspection request from that one and apply it to the production endpoint. We do the usual Verb proxy stuff. We start clicking on everything on the home page, capturing all the requests in Verb. Kind of at least see what queries the front end is using at that point to give us a little bit of insight into what their schema might look like. I also like to do a thing that I like to call field stuffing. Feel free to think of a better name for it. What I'm basically trying to do is brute force the schema. So I get some of the objects that I've collected in Verb from clicking on the front end, and I just start adding random fields to them and see what you get back. This one you see here is that actually worked. I captured a request for a user object in there with name and status and all this stuff, and I added underscore password in there and got the hash password back. Right? Because they figure, well, introspection schema is turned off. Right? Queries are turned off. So there's no way for them to know that they even have access to this stuff. So just guess, right? Start feeding in a word list and randomly sending requests with intruder to try and figure out which ones come back as 200s. There's also another really brilliant feature of GraphQL that makes me really happy, and that is suggestions, right? So, we should all be open to new ideas. GraphQL is no different. So in this case, I'm trying to send it a mutation to create a user, but I left the E out of user, which is kind of a typical thing to do. And GraphQL is nice enough to say, hold on a second, we can't actually do that query, but that's pretty close to something that we can do. Did you mean that you wanted to create a user, or create a profile, or create an avatar, or create a session? And, of course, I'm like, yeah, that's exactly, I just typoed, my bad. That's exactly what I wanted to happen. So, that's a pretty handy feature that they put in there. So now let's take a look at some attack techniques. Nested objects as root objects, right? So we saw earlier how you can nest your objects, underneath your root object, and these can be deeply nested, 5, 6, 7 levels deep on really complex schemas. So basically, we're just gonna take this user object here, we're gonna pull out the friends, and we're gonna just make a request for the friends. On its own, I've had this return, not the exact field. In this case, I've had it return every friend in the database. So that's pretty interesting. It seems to be that the more deeply nested the field is, the higher likelihood that this is going to work. And this is all, their authorization logic is set up correctly. They're not checking. There is no authorization logic around fields itself. There's only authorization logic if fields is nested within a user. So you can pretty much query any of the nested ones as root. Works right. Yeah. So we can also send malicious queries to try and do some nasties. If you take a look at this, these types here, we have a thread and a message, and then, the thread wants the message wants the thread. You can kind of see some circular reference starting to happen here. This research was done by Matt Stoiber. I want to give him, I didn't figure this out myself. I read a blog post about this. It actually works. So, basically, with all the circular reference, what if we send in a query that looks like this? Right? Just 10,000 rows nested deep of messages asking for threads, for messages, for threads, for messages, for threads. Hopefully they're not in like an AWS auto-scaling group, and they're going to get like a $50,000 bill at the end of the year. There's, it's going to shut their servers down completely. There are some mitigations to this that we can talk about. I'm going to talk about a little bit later at the end, just to quickly touch on. But this is a real problem, right? So there's, in the schema, if they're making an update, they're planning to introduce a new field to replace a previous field. They will mark that previous field as is deprecated true. So that's basically used for the dynamic documentation building. When you're looking through, you find these fields, and it'll be like, oh no, sorry, this field's deprecated. You can't actually use it. But sometimes you still can. It's all about the way the resolver and directive logic is set up on the back end. If they didn't implement that properly, go ahead, make the request anyway, man. You never know what you're going to get back with this stuff. You're relying on the time available for developers to get this done, and that time is assigned by the business side, so that much raises the likelihood that there's these mistakes in here. I've definitely queried for deprecated fields and got information back. It's sometimes sensitive. Right? So, if you do have authentication or mutations are available, definitely try and send a mutation to create yourself some kind of access to the database. This is a contrived example of something that I've actually had work. Create a new user in the system with admin privileges because their authorization logic around the create user mutations wasn't set up correctly, and I can just log in as admin. It's beautiful. So if we send this request and we get these ID, title, admin, email fields back, then we know there's something juicy going on back there, and we continue to test. So SQL injection, right? Obviously, we're just going to put a custom injection marker in there. Type this through SQL map. Now SQL map knows how to read and inject the data in the correct spots. Since GraphQL uses resolvers to facilitate the execution of this application logic under the hood, it is up to the developers to implement the proper validation, sanitization functionality. So let's kind of just take a look at that. It's pretty straightforward. We're going to throw a backtick at the end, or we're going to throw an asterisk in there. And, we know that this is expecting to receive an ID due to the schema. So by reading the schema, we know exactly how to build the query. And now we know exactly where we can start to perform our tried and true SQL injection attacks from. This is some research by a guy named Pete Corey. He did some great research about NoSQL injection attacks against GraphQL. So since GraphQL allows you to use custom scalars, you can also just accept JSON objects as long as you build out the scalar validation logic in the back and set it all up with the resolver function, no problem, right? So then it just comes down to how are the developers treating these custom JSON objects, right? So let's take a look at a resolver function, a typical resolver function here. You can see that our user data is being passed straight into the user-defined function. It's not going through any kind of validation, sanitization logic, because this is super convenient, right? So let's say they have it's a user find. So the front end of this is you're going to search for a user, and they want to give you nice fancy filtering functionality. So they're going to hold all of the different regex that they're going to search against these fields on in the front end and just pass them along with requests to the back end. We can capture that and send a query like this, where we're basically just going to tell it, you should just give us all the email addresses for everybody in your database, And since you're going to let us overwrite your fields logic too, instead of just give us the email addresses back, give us all the information back. You never know what you're going to find out there, guys. It's the Wild West. I'm telling you. So, just kind of go real quick. What's your kind of workflow when you're working with a graph? When you're doing a pen test against a GraphQL endpoint, first you need to enumerate all your endpoints. Test to see if introspection queries are available. If they are available, then yay, we're all happy. We can retrieve the schema. We can spend a week and a half parsing through 80,000 lines and building queries and mutations for all of these things. We can add our custom injection markers. We can send all of these requests, proxy them through Burp Suite, and maybe profit if we don't die of boredom first. If introspection is not turned on, we've got to capture some requests in the traditional sense. Parse and build queries using some kind of like field stuffing, object stuffing, see what else we can force it to do. Then add our custom injection markers, and same thing all the way to profit. Right? So that's basically your basic workflow that you're going to have to follow. So let's talk for a second about protecting GraphQL. Just don't enable introspection queries unless you absolutely have to. I see it all the time, and I talk to the developers, and they're like, oh, but convenient. And I'm like, awesome, let me show you what I can do with this. And then after I show them, they're like, we should turn this off. So, yeah, definitely enable it, or only enable it if you absolutely have to. For instance, like GitHub has theirs enabled. They absolutely want to share all of the information in their database. The database that it's hooked to doesn't have private information. It's a publicly available data schema. That's okay. The whole thing was designed for that. Oftentimes that's not the case. So work with your developers if that's kind of your job here to make sure, when you're doing these tests, let them know that although it's like recommended in the documentation and this is how the whole thing's designed, it also allows you as an attacker to really glean a ton of information and attack vectors from their back end. I feel like I shouldn't have to say this. Don't trust users for my data. It's 2019. I'm still having to tell people to always validate and sanitize their inputs. Well-tested solutions exist for enabling authorization and authentication. Use them. Don't let them roll around. Use the tried and true stuff that's out there. It's not that hard to implement. It'll do field level authorization checks, all that good stuff. Make sure that you're testing any new objects and fields and mutations for authorization bypasses and things like that whenever you push out a new release. And really understand how your GraphQL server implementation works. That's less on you guys, more on the development side, but pass the information along to them. They need to know this stuff. It's worth spending the time to really research. The $20,000 bounty paid out was simply for these reasons. They didn't test the new nodes field. They don't really understand how their new implementation works, and they made assumptions. And they're lucky that this got caught by somebody doing a bug bounty. Otherwise, it could have been pretty disastrous for them. As far as the malicious queries DOS, there's a thing called query cost analysis, and there's some libraries out there that do this that basically they go through, they take your query and they kind of do some analysis on it and come up with a kind of complexity score. And if that complexity score is more than a certain threshold, then it will just deny the query altogether. Right? So not a lot of people know about this. They don't actually think, they don't think like we do. So, but these libraries exist. They're not tough to implement, and they'll save you a huge AWS bill at the end of the day. Do security-focused code reviews and train up your developers with secure coding skills. So there are some existing attack tools that are available. Paolo Stagno, I'm just saying his name. Voidsec created a tool called the GraphQL Security Toolkit, which you basically pass it a GraphQL endpoint, and it'll build a whole bunch of queries for you. And in place of the user data, it'll put kind of the type that it's supposed to be. Go in and kind of put some, fill that in with some data that you want, and start making some requests against there. I talked to him. He did say that he's releasing a burp extension to this also, which would be pretty cool. I'm looking forward to trying that out. Thanks, Paolo. So I created a tool called Shapeshifter. Just kind of run this video for you here, so you guys can see it. So with Shapeshifter, you're basically going to pass it your endpoint, and you're going to pass it a proxy, which in this case is going to be Verb Suite, right? So you can see it kind of start to run. Now, what it's doing here is it's making a matrix of a whole bunch of different version numbers and a whole bunch of different common GraphQL endpoints for the common implementations that are out there. And it's kind of searching through, just trying to do the enumeration for you to find where that actual GraphQL endpoint is. So it can take a minute. It's a large matrix through there. And of course, this is it's all open source. You can go through, add your own fields that you want to check for, add them into the matrix. Then it's going to write out a whole bunch of queries after it. So once it finds it, gets the introspection, runs the introspection query, gets the response back, parses it, builds a shit ton of queries, and it actually will look at the scalar type and inject an actual real value for you into that. And then it's going to start sending all of these requests. You can kind of see them on the left with burp as I'm scrolling down there, them going through. If a query fails, I'm parsing that query response and looking for a suggested field, and then I'm going to rewrite the query on the fly with that suggested field to try and get a 200 response for you, right? So this can take a minute. You see them kind of building up over there. What you get at the end is basically a whole bunch of successful queries that can actually be made in Verb Suite. So you can just go in there and filter by 200 responses, and then start grabbing those, setting them to intruder. I'm only at 5. Thought I was going to be a 10, man. The other guy was a 10. Thank you for your candid input. I appreciate that. How's that? Yeah, I'm releasing open source. Yeah, I am. It's all Python. Going to be refactoring the entire thing. Right now it works. It's not pretty, but give it a few weeks. I'll be adding some new features to it. I'll really bumming it out a little bit more. So that's kind of what you get at the end now. You can filter, start sending these requests to intruder. Another feature I want to implement is once it finds all these 200, like on the roadmap here, once it finds these 200 responses, it's going to rewrite all the queries and automatically put SQL map custom injection markers in there. So you can just pass all these on the SQL map and go drink some coffee, get something to eat, come back an hour and a half later, and it'll have tested all of your endpoints for SQL injection, all that good stuff. So there's another tool that I like to use by a friend of mine named Mike Hodges called Hide and Sneak. Basically set this whole thing up. Hide and Sneak allows you to set up ephemeral cloud infrastructure to do domain fronting. So now I proxy my Shapeshifter through that, and each request is sent by a different cloud CDN. So it's really hard for them to notice a pattern in your incoming requests and kind of start to block you since you are making a lot of requests. It'll just look like it's coming from Google Cloud CDN, all this good different stuff, randomizes it on its own. So these two tools paired together, I think, are really powerful and really give you a huge head start on that roadmap and workflow from having to manually parse through all this stuff. So it should give you a leg up and really reduce the time it's going to take to effectively pen test a GraphQL API. If you're not really writing all these responses, you're not really pen testing it to the full capability that you should, and there could be stuff left over in there that you missed due to sheer time constraints, right? No one has time to actually parse through and do all of this different stuff. So I hope this tool gives you guys a leg up on your next pen test if you run into a GraphQL endpoint. That's kind of all I have. You have any questions and stuff? Okay, great. Yes. So, yes, there's rate limiting on GraphQL. I haven't found a case where there's rate limiting on GraphQL. It's not built into the GraphQL spec at all. So, if they decide to implement some kind of rate limiting, then there will be rate limiting. But then you can use myCodge's hide and sneak to domain front, and now it doesn't know where the queries are necessarily coming from, so you're going to bypass that rate limiting by doing that. Unless there's an auth token involved, in which case